All right, so here we're thinking about current measurement. This is the same circuit we've been working with. I have two batteries in sequence. So here's the first battery from here to here. That's about 1.5 to 1.6 volts. And then 1.5 volts again on the other battery. They're connected in sequence. So I get overall 3 volts across here. Across that on the other side, I have an LED that is connected to the battery on this side. And then the LED is connected then to a resistor, which is connected to a switch that is connected back to the lower end of the two batteries. Now, if I press the button, then I connect the circuit through and then I light the light bulb. Now, suppose I want to know how much current is actually passing through the LED. Now, it turns out that because the LED is in sequence with the resistors, in sequence with the batteries, then it's the same current that is passing through all of them. Suppose I want to know how much current is passing through the LED. The measurement of the current is different from the measure of the voltage. The voltage you measure across, so you don't need to break the circuit. But for current, you really do need to break the circuit. So that's the first thing we're going to do. I need to break the circuit, let's say, before the LED. So I'm going to break it between the battery and the LED like that. Obviously, the circuit now is not connected because I've disconnected the battery, put it on 27, and the leg of the LED is on 17, and these two rows are not connected. However, I could connect them with an extension jumper wire. I can go from here to here just to show you that now I've reconnected it from 27 to 17. I don't need that wire though. I'm just showing you that this is where, in place of that wire, what I'm gonna do is I'm going to connect the ammeter, the multimeter. The measurement of the current is going to be connected in sequence with the thing that you want to measure the current through. So I'm going to put it in sequence with the LED. So this is where I'm connecting to 27 and 17, and then I'm going to measure, I'm going to put the multimeter in between these two, and so the current is going to go through the multimeter and then come back and then get into, I can flip it across like that. We'll see what effect the flipping will do in a second. But here what I'm saying is that I'm going to put the ammeter in here. So that means that the current is going to come through the ammeter, and then come through the LED and so on. Now, obviously, right now, the circuit, this branch is not connected. So if I press the button, nothing happens. And then I want to put the ammeter in here, but I want to think about what setting to put it on. Now, I'm going to measure DC current. So it's going to be one of these settings. If I want to measure something between 200 milliamperes and 10 amperes, then I really need to put the red, I need to plug it in here in the 10 amperes part. But if I'm going to measure anything that's less than 10 amperes, so maybe starting from here, then this is the right place to connect. Now I know that the current in here, because of the size of the resistor that I put, that the current is not going to exceed the 200 milliamperes for sure. So that's where I'm going to place my dial. I'm going to place my dial at 200 milliamperes. Now, obviously, if I connect it now, because the circuit is not powered, because the switch is not pressed, then the reading is still going to be 0. However, once I press the switch, let me see, how can I do this? I'm not covering. Here we go. So press the switch. You can see that the light bulb is turning on. That means that there is a continuous path. So it's coming from the battery through the ammeter, coming out from the other side, and then connecting to the light bulb, to the LED, and then through the resistor and back to the. Now, what I'm getting now is a measurement of 5.1, 5.0 of milliamperes, because I have it on 200 milli. That's the maximum I can measure. So that's about 5.0. So 5 is less than 20, so maybe I can go down to 20 to get a little bit more of an accurate reading. So again, I'm going to connect the multimeter between these 2 points. So the current is going to pass through it, and I'm going to see the measurement that I get. Here we go. It's a little bit more accurate. So it's not exactly 5. It's more like 4 point something. Let me just make sure that everything is connected, because it's kind of jumping around. So I'm just going to make sure that everything is properly connected. And let's try that measurement again, because it was jumping around a bit. So it's about 5 milliamperes. okay? Now, what the positive sign is meaning is that the current is actually going through the red and coming back through the black. Now, if I flip that and I do the measurement again, so now I'm connecting the black to this side and the red to the other side, you'll see that the measurement now is negative 5 milliamperes. That means that the current is actually going through the black and coming out through the red of these two leads. And that's how you measure the current. Now suppose I want to actually measure the current between the LED and the resistor. Then instead of doing it like this, then I'll bring the LED to this side. And again, the circuit now is not connected anymore, it's a broken circuit. However, what I'm gonna do is I'm going to connect from the other side of the LED, which is now on 26, and then I'm gonna move this to 16. Now, obviously, if I keep it on 17, then nothing happens, right? The circuit is not connected because the 17 here is not connected to the 16, the leg of the resistor. So I need to move this to the leg of the resistor, the same row as the leg of the resistor. So now if I connect the ammeter between 26 and 16, then I can measure the current in the branch. Now, as I said before, because the LED and the resistor are in series, then that means that the current that passes through one passes through the other one. So I'm going to get exactly the same measurement.